Let's take a look at Arduino direct port access. Now what we're going to do is we're going to do a blink program. We're going to blink pin 13 using port B instead of digitalWrite, okay? And we use this instead of digitalWrite because direct port manipulation is much faster, and then you can set and clear multiple pins at the same time. Now on Arduino Nano, port B controls digital pins 8 through 13, and port C is for the analog pins, and port D is for the D0 to D7 pins, okay? And each port has 3 registers. We have a DDR register, it's a data direction register, and that just sets the mode of the pin to being either an input or an output. And then the port output register controls whether it's high or low. And then there's a pin register, and that's the input register, just reads the state of the pin, okay? Now, a port has 8 bits, and each bit corresponds to a physical pin, okay? And then on the Arduino Nano, bit 5 in port B register controls pin D13, which is our LED light, okay? So what we want to do here is we have this DDR register, and we want to put a 1 in the DDR in the 5th position here, and that's going to take our D13 and make that set D13 as an output, okay? If this bit 5 here is a 1, then D13 is an output, okay? And then at port B here, if bit 5 is a 1 here, we're going to set the output to high. That's our output register, okay? And then the pin's going to go high. If we make that a 0, then the pin's going to go low, okay? Now I said they have 8 bits, and so port B has 8 bits, and the last 2 are tied to the crystal, so we don't use those. So now we have these bitwise operators, and they work directly with individual bits. This bar, that's an OR operator, okay, and this ampersand here, that's the AND operator, and then we have this squiggly line here. That's it's on the left side of the one on the keyboard, and that's a NOT operator. And then we have this, I think it's called a cadet. It's if you shift the 6 key, that's what you get there, and that's an XOR operator, okay? So here's a program here, and what we're going to do is we're going to set pin 13 as an output. So in order to do that, we want to do this here. We want to put make this pin 5 here a 1, put a 1 in there. So what this does here is this says 1, and we're going to shift left DDB 5, okay? So what that does, it shifts the binary value 1 left by 5 bits. So we start a 1 here, and then we go 5 places over. That way we have 5 zeros here and a 1, okay? And then this DDRB here, that's the bar there, that's our OR operator, and that just sets the bit to 1. And it makes the PB5 or pin 13 an output, okay? So that's all we have to do to make that an output. So now we want to make the pin 13 high, turn the light on. So we do the same thing here. We go left by 5 spaces over here, and we turn that pin on right there, okay? And then port B, the bar there, the OR operator, that sets a 1 in that position, okay? So now we have our pin 13 high, and it's on. Now we want to turn it off. So there's a little bit of a trick to do that. We have this here. This is the NOT operator. So we have NOT, we shift left NOT, 5 places. So what that does, it forms a mask, and it takes the bits and reverses all the bits here. So we have all 1s and a 0 in that spot. They're not really, this is just kind of a placeholder here. So then we take our port B here, and an AND here, this ampersand here, an AND operator, and we put those 2 together. So we have this is our original what we came, and then we changed it to this. And now on the AND operator, it's going to be a 1 if both bits are 1 here. And in this case, you have a 1 and a 0, 1 and a 0, 0, 1, none of them line up, so it's going to be zeros all the way across. So, and that's going to be take your pin 13 or DB5 and make that low, okay? So it just clears bit 5 into 0, okay? Just a way of clearing it out to 0 there, okay? So that's all there is to it. We're just taking our data direction register, making it an output. We're taking our port register, either making it high or low, okay? And now if you want to do this, I'm going to do it on the scope so I can see how fast this thing goes. But if you don't have a scope, you can just put a delay in here and to see if it actually works. So you can put delays in, and then you'll see the light blinking. It's going to go so fast, and it's not going to blink without those in there. So we're going to go over to the scope, and let's see how fast this thing will run, and see how many clock cycles it takes to turn the light on and off. Okay, so we'll see over at the scope. All right, here we are at the oscilloscope, and this pulse here is the time it takes to turn the LED on and off, and it looks like it's 128 nanoseconds. Now, the Arduino running at 16 megahertz, the clock cycle is going to be, one cycle is going to be 62.5 nanoseconds. So it's about two clock cycles here that we can turn the thing on and off. So that's pretty fast. Anyway, thanks for watching.